Hello, my name is Nazira binti Zakaria. I will explain on the principle of ultrasonic testing.
Assalamualaikum, my name is binti Zemi, and in this video I will explain more detail about the ultrasonic testing procedure.
Hi, my name is binti Badrul. I will present the standard for ultrasonic testing.
Hello, my name is binti Zanidin. I will present advantages and disadvantages of ultrasonic testing.
One of the most widely used non-destructive testing method is ultrasound testing. It can be used to find internal flaws, find surface and subsurface discontinuities, measure thickness where other methods fail, assess physical characteristics like elastic modulus, examine metallurgical structure like grain size and more. Measurements and inspection are performed using high-frequency sound energy. Ultrasonic examinations can be conducted on a wide variety of material forms, including casting, forgings, welds, and composites. Ultrasonic testing is a very versatile inspection method, and inspection can be accomplished in a number of different ways. Ultrasonic inspection techniques are commonly divided into three primary classifications. First, pulse echo and true transmission relates to whether reflected or transmitted energy is used. Second, normal beam and angle beam relating to the angle at which the sound energy enters the test article. Third, contact and immersion relate to the method of coupling the transducer to the test article. In addition to being widely employed for numerous industrial applications, the ultrasonic technique is actually quite adaptable and is also heavily used for numerous research purposes. It does not pose any health hazard to the operator or to the people standing nearby. Widely used in industry for quality control and incoming material inspection. There are many different types of failures that can be found, including voids, cracks, inclusion, segregation, lamination, burst, flakes, and etc. These flaws may be built into the raw material or may be the product of manufacture and heat treatment. The flaws may also develop throughout the course of service due to the factor like corrosion, creep, and fatigue. What is the basic principle of sound? A vibrating body produces sound which is transmitted as a wave. Sound waves travel through materials by vibrating the particles that make up the materials. The frequency of the wave, the number of vibrations or cycles complete in a given amount of time, determines the pitch of the sound. Ultrasound is sound that has a pitch that is too high for the human ear to hear. Ultrasonic waves are very similar to light waves in that they can be refracted, and focused. Reflection and refraction occur when sound waves interact with interface of different acoustic properties. When a wave contacts an interface at an angle other than 90 degrees in solid materials, its vibrational energy can be split into different wave modes. Ultrasonic reflections from discontinuities or geometric failures enable detection and location. The velocity of sound in each material is constant and can be only varied by changing the mode of energy. If there is a defect or discontinuity in the path of sound wave, those waves reflect back to the receiver, where the transducer converts the sound wave to electrical wave and displays them on the screen. The measurement of sound wave from crest to crest determines their wavelength, lambda. The time it takes a sound wave to travel one complete wavelength is the same amount of time it takes the source to execute one complete vibration. The sound wavelength is inversely proportional to its frequency, which is lambda is equal to 1/f. Several wave modes of vibrations are used in ultrasonic inspection. The most common are longitudinal, shear, and relay surface wave. What is the principle of ultrasonic inspection? Ultrasonic waves are delivered into a substance and move in a straight line at a constant speed until they encounter a surface. Sound wave energy is reflected and sound is transmitted at surface contact. The amount of reflected or transmitted energy can be measured, providing the size of the reflector. The sound travel time can be measured, which offers information on how far the sound has traveled.
Most commonly used ultrasonic testing technique is pulse echo, wherein high-frequency sound wave beams, normally range from 1 to 5 MHz, is introduced into a test object and reflection are returned to a receiver for internal information over the part's geometrical surface. The basic method of ultrasonic testing is transforming a voltage pulse to an ultrasonic pulse using the transducer. Pulse echo testing, the same transducer emits and receives the sound wave energy. This method uses echo signals at an interface, such as the back of the object or an imperfection, to reflect the wave back to the probe. Transducer used for the traditional ultrasonic testing consist of a piezoelectric crystal enclosed within a plastic or stainless steel housing. The piezoelectric crystal expands when electrical charge thus generating an acoustic wave. The signal travels to the object with respect to its geometry and existing defect, and then it is transmitted to another transducer or reflected back to the original transducer. Defects are detected if they produce a change in the acoustic impedance in the path of the ultrasonic beam. An open crack filled with air has very low acoustic impedance, so it will reflect virtually all the acoustic energy incident on it. Hence, the sound will travel to the material and are reflected back from the crack or flaw. Defect and flaw affect its way, and a small portion of the pulse will be sent back to the transducer before it hit the end of the object. Results are shown as a line plot with an amplitude on the y-axis representing the reflection intensity and distance of the time on the x-axis, showing the depth of the signal to the material. The CRT screen is calibrated to show the separation in distance between the time of arrival of a defect echo as that of the back wall echo of the specimen. Therefore, the location of the defect can be assessed accurately. Next, through transmission testing. This method is used for the inspection of large ingots and casting, particularly when the attenuation is high and gross defects are present. The method does not give the size and the location of the defects. In addition, good mechanical recoupling and alignment of the two probes are essential. Through transmission testing, use an emitter to send the ultrasound wave from one surface and a separate receiver to receive the sound energy that has reached the opposite side of the object. Imperfections in the material reduce the amount of sound that is received, allow the location of flaws to be detected. In this method, two ultrasonic probes are used. One is the transmitter probe and the other is the receiver probe. These probes are situated on the opposite side of the specimen. Discontinuities in the sound wave may result in a partial or total loss of sound being transmitted and be indicated by a decrease in the receiver signal amplitude. True transmission is useful in detecting discontinuities that are not good reflected, and when signal strength is weak. It does not provide the deep information, but in this method, the presence of an internal defect is indicated by the reduction in signal amplitude, or in the case of gross defect, complete loss of transmitted signals. explain about the ultrasonic testing procedure. First step is an object or test piece need to be identified to perform the ultrasonic testing. Second, the oil or gas is applied to the probe to smooth the rubbing and clear data. The probe is placed on the object where electrical waves are converted into high frequency sound wave. Next, a sound wave will propagate through the object. If any flaws or defects come along the sound wave, the wave will reflect back to the probe. Again, those ultrasonic waves are converted into electrical wave and displayed on the screen. Last but not least, further data is analyzed to give the result of testing.
In ultrasonic testing, there is also a need for reference standard. Reference standards are used to establish a general level of consistency in measurements and to help interpret the received signal, to validate the equipment, and the setup provides similar result from one day to next and also help the inspector to estimate the size of the flaws. Calibration and reference standard for ultrasonic testing come in many shapes and sizes. The type of standard used is dependent on the NDE application and the form and shape of the object being evaluated. The material of the reference standard should be the same as the material being inspected, and the artificially induced flaw should closely resemble that of the actual flaw. The first one of the standard is the IIW type calibration block, and this standard shown in the above figure is commonly known in the US as an IIW type reference block. IIW is an acronym for the International Institute of Welding. IIW type blocks are used to calibrate instruments for both angle beam and normal incident inspection. Some of their uses include setting metal distance and sensitivity settings, determining the sound exit points and refracted angle of angle beam transducer, and evaluating depth resolution of normal beam inspection setup. The second type is the miniature angle beam, or we call as ROMPAS calibration block. This miniature angle beam is a calibration block that was designed for the US Air Force for use in the field for instrument calibration. The block is much smaller and lighter than the IIW block, but perform many of the same functions. The miniature angle beam block can be used to check the beam angle and exit point of the transducer. The block can also be used to make metal distance and sensitivity calibration for both angle and normal beam inspection setup. The third type is the AWS shear wave distance sensitivity calibration, or we call as DSC block. This block looks very similar to the ROMPAS block. This block closely resembles the miniature angle beam block and is used in a similar way as the DSC AWS block. This block is used to determine the beam exit point and refracted angle of angle beam transducer, and to calibrate distance and set the sensitivity for both normal and angle beam inspection setup. Next is AWS shear wave distance calibration DC block. The DC block has a very simple extruded semicircle shape. The DC AWS block is a metal path distance and beam exit point calibration standard that confirms the requirement of the American Welding Society (AWS) and the American Association of State Highway and Transportation Officials (AASHTO). Next type that we use is step and tapered calibration wedges. Step wedges look like mini staircases. They are often used to calibrate for thickness measurements. Step and tapered calibration wedges come in a large variety of sizes and configurations. Step wedges are typically manufactured with 4 or 5 steps, but custom wedges can be obtained with any numbers of steps. Tapered wedges have a constant taper over the desired thickness range.
There are several advantages of ultrasonic testing. First, internal defect can be detected and such when a validated procedure is applied. The ultrasonic testing technique has the ability to get the information about the part that is being examined, such as the presence of flaws, since the technique is sensitive. Generally, sensitivity increases with higher frequency and shorter wavelength. Next, ultrasonic testing just requires minimal part of preparation. Besides, only single site access is needed in ultrasonic testing when the pulse echo technique is used. The pulse will continue to hit the back wall of the object. If there are no flaws, it will be reflected and travel back through the object. Furthermore, UT provides instantaneous results. There are several pieces of ultrasonic equipment that have been used to get an instant result, such as ultrasonic transducer and probe, flow detector, thickness gauge, and automated UT system. Next, the ultrasonic testing has more uses besides just identify flows such as thickness measurement, and it also has good accuracy when predicting size and shape and reflector position. Because of the way they work, ultrasonic sensors are highly accurate and can be used to detect very small alteration in position. They can also measure the thickness of an object as well as the depth of the parallel surface. Besides, the advantages is that of the penetration of flow detector or measurement is superior to other methods. Next, automated method can create detailed image. The information required to create an image is provided by the sound signal amplitude and the length of the time it takes for the wave to cross the body. Other than that, the ultrasonic technique is very versatile indeed, and besides being widely used in various industrial applications, this technique is also extensively used for various research applications. It does not pose any health hazards to the operator or to the pupil standing nearby. Ultrasonic testing has several disadvantages in addition to its many benefits. First, in certain materials like austenitic steel, the large grain size found in wells can cause attenuation, which may mask effect. The average grain size as well as its influence on the propagation velocity and attenuation coefficient of ultrasonic wave also affect the wave frequency propagating through the material. Following that, ultrasound transmitter require access to the surface. Next, ultrasonic testing skill and training is more extensive than with some other methods. A high degree of operator skill and integrity is needed, hence the need for trained and certified personnel. Furthermore, false signal and incorrect signal interpretation can lead to needless repair, which is why any ultrasonic examination should follow a validated procedure. Other than that, reference standards are necessary in UT for both the characterization of flows and the calibration of the equipment. Calibration, qualitative and quantitative data are all determined using reference standards. Therefore, obtaining results that are scientifically valid depend greatly on the quality and purity of the reference standard. Next, materials that are raw, irregular in shape, very small, exceptional thin, or not homogeneous are difficult to inspect. Besides, in most examinations, there is no permanent record of the inspection as there is in radiography. However, more recent equipment does offer this facility. Next, to promote the transfer of sound energy into the test specimen usually require a coupling medium. Ultrasonic testing is also more expensive than other methods. In industrial application, ultrasonic testing is widely used on metal, plastic, composite, and ceramic. The only common engineering materials that are not suitable for ultrasonic testing with conventional equipment are the wood and paper products. Lastly, ultrasonic testing difficult to use in thin material with minimum thickness is 6 mm.
So, in the conclusion, ultrasonic testing is one of the best testing in the non-destructive testing. That's all from us. Thank
Thank you.